Welcome to my video, Introduction to Exponential Functions. An exponential function is any function for which the rule specifies the independent variable is an exponent. A basic exponential function has the form, so there would be like an exponential function. A would be a number greater than 0, not equal to 1, and raised to some power, the power of x. So that's an exponential function. The domain of a basic exponential function is considered to be the set of real numbers, unless otherwise specified. So our real numbers, like -2, 1.29, 1/3, √2, basically it's going to be the rational, irrational, plus and minus numbers, 0, really just not complex or imaginary numbers. All right, next let's look at some examples of exponential functions. So f of x is equal to 2 to the x, where that would be our a. There's the power x. F of x is equal to 1/3 x plus 4. G of x is equal to 2 times 3, where 3 is raised to the x minus 1 power. And another one would be g of x is equal to 1/2 raised to the x power, and then L of x is equal to 2 to the minus x squared. So there's a power involved in exponent. That's what we call exponential functions. Now we'll look at some of the laws regarding exponential functions. The first one is the product of powers. So this is when you have two exponent numbers that are raised to a power multiplied together. If the base is the same, in this case it's just a, the result is a raised to the s plus t power. All right, let's look at an example. So we've got 3 squared times 3 to the 4th is equal to 3. Now we add the exponents together, 2 plus 4, so that's equal to 3 to the 6th power, and plug that into your calculator and you get 729. So our next one here is power of a power. So we've got a to the s. Now this whole quantity is raised to the t power. That's why it's power of a power. And so in this case, the power of the number a is just the product. In this case, we've got 2 to the 3rd power. That whole quantity raised to the 4th power. Now that's just 2 times 3 times 4 is equal to 2 to the 12th. Putting that in our calculator, we get 4,096. So there's an example of power of a power. Now we want to look at two more laws. This is power of a product. So here's a product of two numbers, a and b, raised to the s power. That's equal, it can be broken out to a to the s times b to the s, as long as they're the same power. So to do an example of this, we've got 2 times 5 raised to the 3 power is the same as 2 to the 3rd times 5 to the 3rd. 2 to the 3rd is 8 times 5 to the 3rd is 125. 8 times 125 is 1,000. Now the next one is the negative exponent. And that's a to the minus s is just equivalent of 1 over a to the s. Looking at an example of that. So 4 to the minus 2 is equal to 1 over 4 squared is equal to 1 over 16. That's an example of a negative exponent. Here's two more laws. One is the zero exponent. Any number raised to the 0 power is just equal to 1. So 7 to the 0 is equal to 1, or 8 to the 0 is equal to 1. Very simple rule. 1 raised to any power is just equal to 1. So 1 to the 7th is equal to 1. Those are two pretty simple, straightforward rules. Next, let's look at quotient of powers. So in this case, we've got a to the m divided by a to the n power. It's just going to be the difference, where a is not equal to 0. Then we would get a number over 0, which would be infinity, and that would be undefined. So let's look at an example of that. So we've got 5 to the 7th power divided by 5 to the 4th is equal to 5 times 7 minus 4 is equal to 5 to the 3rd, which is equal to 125. Now our last one is power of a quotient. Let's see what that means. So you've got a quotient, which is a divided by b raised to the power n. That can be written as a to the n divided by b to the n. But in this case, b cannot be equal to 0, or you're going to get things undefined. It's going to blow up. So let's look at an example. So 3 divided by 2 squared, that quantity, is equal to 3 squared divided by 2 squared, which is equal to 9 divided by 4. Well, I hope you got a little bit out of this short introduction to exponents and some of the rules. Thank you for watching.